those. We set up a differential equation for phonon modes, which was basically based on F equals ma. Solved that system of equations, and we came up with the dispersion relation. Then we used the dispersion relation here to calculate all kinds of things like frequency, and then we calculated density of modes, okay, and we calculated things like specific heat, all these kinds of things, right? So once we get this sort of distribution of possible modes, if you will, then we can do all kinds of things with it, right? That's the underlying sort of physics, okay? Then we went to the electrons, went out to the electrons, and we looked at, for example, conductors and semiconductors, and we said, all right, the appropriate physics to apply there is Schrodinger's equation. We solved Schrodinger's equation, we came up with a system of equations, or we sort of tried approximations and came up with a system of equations here. And rather than the dispersion relation, it is now called the bands, right? So now you have bands. So you have rather than omega, okay, omega versus k, now you have energy versus k, right? And so now you have these bands here. And again, you get sort of funny type things. In the nearly free model, the energy is proportional to k squared, but funny things happen out at near the zone boundaries here, okay? And then you can have a density of states rather than density of modes. Now you have density of states. Once you now have density of states, you can do all kinds of things, calculate all kinds of things with that, okay? And the third sort of area we went into is now photons, okay? And so rather than, so now we applied Maxwell's equations, came up with some differential equations to solve there, and now we came up with a dispersion relationship now that was for optical situation, right? And we didn't do much beyond that with phonons, but that's one thread that sort of weaves through this whole class. Okay. I have no idea who even asked the question or if someone was answering that question.
No, but it's information that can help us.
Okay. Yeah, you had a question about the e-bike frequency, right? All right. So the dBi frequency is a concept that sort of helps us hang on to simpler models, just as the Fermi level sort of helps us hang on with nearly free electron models. Another thing that is a common thread throughout the course was nano, right? Is nanosizing things. What happens to materials as you make them smaller? Scaling arguments, as you scale things down. Some things happen without even changing material properties of things. But some of the material properties can change as you scale things down. Okay, have we stalled long enough for you to come up with another question? So you guys are ready for the final tomorrow, huh?
Let's do it now.
Okay.
Well, leave Wednesday and say we did it Friday. We'll stall right.
One question. They should very helpful question.
Plus 40 bonus points. For the early bird schedule.
So no other questions?
Friday's pretty cool.
Yeah.
What's that?
2 o'clock.
Well, you can make us come down from 2 o'clock on Friday.
Okay. It's not me. I thought I explained that very clearly last night. And it is absolutely not me.
So much cruel.
That way you won't have two midterms in a row. That's how they do it. That's
That's nice.
The other way, then students could have like 3 midterms, 3 finals back to back.
Well, other things too is that some classes are only an hour long, right? But the midterm is 2 hours long. Right? So you can't, you have to be careful how you order them through, right? So yeah, it's not a trivial thing to arrange things so that you don't have conflicts.
Was there any conflict on Wednesday in here?
What's that?
Was there a class in here on Wednesday at 2? There's not a class before?
It's not a question of the room only, but it's a question of students as well. And students have planned out, with it in mind.
At least it's not next Monday. That would suck.
So you have plenty of time. I expect everybody to do really well on it. Chuck, you did great, really quick.
Stop right there, I think.
That's not terrible. This is only 2
You're
weeks.
jinxing us.
Oh, yeah? Okay, if there are no more questions then.
Oh, okay. So she's